Hey guys, welcome to another video. I'm your instructor, Ajay. So in this video, I'm just going to introduce you to the concept of momentum and tie it in with all the concepts that we've learned so far. So to get an intuition for the idea of momentum, let's look at two people. This first guy is moving really fast, so has a large velocity, but he is kind of skinny, so his mass is small. So large velocity and mass small. And the second guy is running a little less quickly, so velocity small, but his mass is large. So maybe he has a bigger body like that. And I'll draw his arms a little bit better. Oh, that was not better, but um, we'll go with it. My drawing skills are not great. Um, so the question is, what if you were to get hit by this guy, Bob or Tim, who would you rather get hit by? You want who would it be more unpleasant to get hit by? Would it be more unpleasant to get hit by Bob or Tim? And it's kind of hard to tell because if someone's moving faster, it's probably more unpleasant to get hit by them. At the same time, if someone weighs more, it's also more unpleasant. And this idea that the how unpleasant getting hit by something is called momentum. Momentum. And momentum is impacted by both velocity and mass. So you have an an increase in velocity and an increase in mass would also increase the momentum, as we saw here. You have a greater velocity, it's more unpleasant to get hit by this person, and if you have a greater mass, it's likewise the same thing. So we get, and the symbol for momentum is P. We don't use M because M is already for mass. So P is equal to mass times velocity. It's impacted by both the mass and by the velocity. Now, how does this relate to some of the concepts we've already learned? Well, I'm going to do a derivation here. Derivation. And to start with the derivation, I'm going to go through some of the concepts that we've already learned. So let's go to force is equal to mass times acceleration. This is Newton's second law. Newton's second law. And now what is acceleration? Acceleration is basically just the change in velocity over the change in time, right? How much your velocity changes over time. If we, I don't know, look at a graph and I'll do red for acceleration, and that's your acceleration. Maybe that's 3 meters per second squared. Then this is acceleration and that's time. Then your velocity graph would look something like this, where your velocity is changing by 3 meters per second every second. So 3 meters per second per second. So that's acceleration. So now we go back to this equation right here, and we substitute change in velocity over change in time to this equation. So you have our net force. Net force is equal to mass times the change in velocity over the change in time. Change in time. Now, why don't we multiply the time over? Because it looks like we have something familiar here. This seems an awful lot like this. So let's multiply the time over and see what we get. So let's do that. Net force times the change in time is equal to mass times the change in velocity. Now, as you can see here, the mass, this constant, this momentum right here, it looks awfully similar to this. So how can we relate momentum to this quantity right here? Well, we can do this. Usually, an object doesn't gain or lose mass while it's moving, so we can assume the mass to be constant. And since the velocity is the only thing that changes, I'm actually going to bring this over here, down here. Let's bring it down here. I'm going to bring it here for further reference. If the velocity is the only thing that's changing in maybe say a person is running this way. Person is running this way, he can run faster or he can run slower. But if the mass stays constant, then the change in the velocity is the only thing that affects the change in the momentum. Right? He can run faster or slower, but he can't gain or lose weight. So the only thing that changes how unpleasant it would be if he was, say, hitting an object is the velocity, is how fast he runs. So we get this. The change in momentum is affected by the mass and the change in velocity. This is a direct result of this right here. This is a result of this. So now we can substitute in this for up here. And so we get net force times delta T is equal to delta P. So the net force times the amount of the time, and we'll discuss what this time really means, but for now I'll just say the time of impact, that is when the person actually hits the thing. We talked about here how unpleasant, talked about the definition of momentum as how unpleasant it would be if a person hit something. Now this time is actually the time that the person is in contact with the thing that he's hitting. And that is equal to the change in momentum. And this is really weird to imagine at first, but as we'll discuss in future videos, it actually makes a lot of logical sense. Alright guys, thank you so much for watching. If you like this video, please share it and subscribe to my channel. I'll see you in the next video.